VLANs, configuration and verification. Well, we've walked into the first of the major topics of the BCMSN video series, and that is VLANs. These things define the fabric of just about every enterprise network that you can find in the world today. They are the separator that divides a network into multiple broadcast domains. So before we get too deep into VLANs and trunking and all the different technologies, I thought I'd just start off with a simple video explaining the foundations of VLANs, what they are, why you'd use them, and some design, and focusing on Cisco's recommendation of using local VLANs. The last thing that we'll talk about in here is VLAN configuration. We'll actually jump into a live interface, talk about how to set up VLANs on Cisco switches, and assign ports to them. Just to make sure we're all on the same sheet of music, I'd like to do a little review of the VLAN foundations. What are VLANs? Well, by default, a Cisco switch sends a broadcast everywhere, right? Every switch does. That's what switches do. But when we set up VLANs, the broadcast traffic is restrained to the VLAN that it was received in. So, for example, you can see on the screen I've got the blue VLAN and the red VLAN. If the blue computer sends a broadcast, it only comes out the blue ports. Red computer sends a broadcast, it comes out the red ports. That's known as separate broadcast domains. We've completely divided those switches up. Now, with that being said, as a side note, we've got these blue computers and red computers sending broadcasts. If that's the case, then what VLAN does that port belong to? Well, you probably guessed it, all VLANs. If a broadcast is going to go out all those ports, then these ports, these white ports, and this is a magic port that has two things connected to it, but you get the point. Those ports send all VLAN traffic, and Cisco calls those a trunk port. Now, I will mention, if you jump out of the Cisco world into any other vendor, whether it's 3Com or HP, they actually define those ports as tagged ports. So when you're thinking about tagged ports and trunk ports, they're kind of equivalent in those two worlds. So with that in mind, setting up VLAN helps you manage your network to really divide it into logical groups. We talked a little bit about this in the first video that opened this whole series. Now, these VLANs are correlated directly to a subnet. It is a one-to-one correlation. So every VLAN that you create needs its own subnet assigned to it. These VLANs can be used for access control to prevent, the blue users from reaching the red users. They can be used for quality of service to say, well, the blue VLAN gets better treatment than the red VLAN, and they get more priority of the bandwidth. And they can just be used for just a great network design. You won't walk into any modern network that has a large campus environment that is not using VLANs. They are, how do you like that? You won't walk into any network with technology from this year and beyond, and the routers and, just about everybody, let me put it that way, uses VLANs. They are a great network design and make it very easy to manage large campus environments. When you are setting up VLANs in your network, Cisco recommends that you design them through a concept called local VLANs. All that means is that the VLANs are constrained to a specific switch block. Now, in the opening video to this whole series, we talked about the enterprise composite network model, remember? And one of the things we talked about there was how we're supposed to design our network in these groups, this access layer, distribution layer, and up here is our core layer devices that really separate the major sections of our network. It could be done by buildings, it could be done by major departments, could be done by technology. For example, over here I have the server block and the user blocks. Inside of the server block, I have VLAN 10, 11, and 12 that maybe divide up my servers, and I've got the email servers in one VLAN, web servers, and so on. And then over on the right, I've got user blocks, maybe the accounting and sales department are VLAN 14 and 15. By keeping those VLANs constrained to the switch network, meaning their switch block, I've created local VLANs. And that's good because now I can implement routing to get to the other destinations. If these guys want to reach the servers, no worries. I can just route them through the core using my routing table, but these all remain routed links because we don't want a broadcast traffic going through the core and hitting other areas of our network. These local VLANs should be created around the physical boundaries. And usually, I know we don't think about things in physical terms anymore because VLANs are completely logical, but they should really be created, physically speaking, with switches that are directly connected. You directly connect access layers to a distribution layer. You directly connect distribution layers to core layers. Those are your boundaries that should contain your local VLANs. The point is, to put it simple, we shouldn't have VLANs that go through the core. They should remain at the distribution layer and stop there. Well, I'm ready. Let's get into the VLAN configuration, just the base setup of VLANs on our switch. I'm logged into a Cisco switch right now. I'm going to type in show VLAN and just take a look at what VLANs I have on the switch by default. Now you can see VLAN 1 right there, the default VLAN, has all 23 ports assigned to it. You can see 1 through 23. This is a 24 port switch, and I'll talk about where port 24 is in just a moment. But below that I have 1002, 3, 4, and 5 VLANs, which are not something that we created. They're on there by default. Those are just in order for Cisco to be an industry compliant vendor, they had to have those VLANs just because the industry standard said you should. Notice it says active but unsupported because this switch doesn't have FIDI interfaces or token ring. Obviously, this is an older standard, but they're there by default. All other VLANs we can create. Now, there's two ways to create VLANs, an old way and a new way. I'll show you the old way first. We can do that by typing from privilege mode, and that's where it's kind of funny because we don't start from global config. You can type in VLAN database. Now a little paragraph comes up that in short says, Cisco is saying, this is a mode we used to like, but now we don't like it, so we're making it go away in future versions of the software. It's being deprecated. So this mode is eventually going away, but this is the only mode many people know. You go into VLAN database, and underneath here you can just type in VLAN 100, followed by name, we'll say IT. VLAN 200. Let me name it sales. Jump back here. VLAN 200, and so on. Now, this mode, and I think one of the reasons why Cisco is trying to make it go away, it's very quirky in the sense that we're used to, how do you usually exit from modes? Control Z, right? I know some of you are thinking you type in exit. Well, most people hit Control Z. And if you hit Control Z to jump out of this mode, it actually undoes everything that you did. It's funny. So when I get out, I have to type in exit. And that's where you get this message, apply completed. Now when I type in show VLAN, I can see default VLAN, IT, and sales. So I've created those two VLANs. With the old way out of the way, let me show you the Cisco preferred way. I go into global config mode and type in VLAN, say a number, we'll say 300, name, marketing. Okay. You actually go into this VLAN sub-configuration mode and name it. And then you can exit back out and do VLAN 400, name, management. Exit out. Show VLAN, and you can see that sure enough we've added more VLANs to our switch that are available, but no ports have been assigned. So to assign ports, I go into global config mode, and I'll just assign the first 10 port. I'll type interface, well actually first 10 ports, let's do interface range, fast Ethernet 0/1 through 10, and I'll do first command switch port mode access. Now let me type the whole command. That command configures this to be hard-coded as an access port. You don't have to do it, but it's very important that you do. Because otherwise, it's in a mode known as dynamic, where it will be trying to negotiate a trunk port with the other side. That, by the way, is a horrible security vulnerability to leave your ports in dynamic mode. You want to either hard code them as access ports or trunk ports. But we'll talk about that more in the upcoming video. Actually, it's coming up next, where we discuss everything trunking. So we've set these to access ports, which means an end device attaches to them. Then I'll follow that up with switch port, access, VLAN, and let's throw these guys in 100. They're the IT ports. Do interface range, fast Ethernet, we'll say 11 through 15, switch port mode access, and switch port access VLAN 200. When I jump out, I'll do a show VLAN, and I can see that I have a status message splicing up my beautiful output. You can see the IT ports, whoop, right there, with a group of ports underneath it, or the IT VLAN, and then I have the sales VLAN with a group of ports under it. At this point, I have completely segmented my switch. The sales ports cannot reach the IT ports, which cannot reach the default VLAN. They are totally separate. A broadcast in those VLAN stays in those VLANs. So that is how we create VLANs and assign ports to them. Now, the last thing I'll talk about, this is a short video just on creating VLANs, is where these VLANs are stored. This is a little odd, but Cisco decided not to store the VLANs in the running config. I'll do a show run and do a little scrolling down, and I can see that, there's my spanning tree, all my commands I typed under my interfaces, and interface VLAN 1, console port, nothing. Nothing about VLANs is in the running config. It's all stored in a file in Flash called VLAN.dat. You can see that file right there on the bottom. The VLAN database file holds all the VLANs that we created and their proper names. That is a little bit irksome, I'll say. I'm trying to think of the right word. Irksome, I guess we'll do for now. Because you may think you clear out your switch. Let's say you erase the config just by doing a write erase or erase startup config. And you think you wipe out the config, but when you reboot, you'll still see all those VLANs there. That can be an issue when we start getting into topics like VTP, because it may accidentally propagate those VLANs when you don't intend to. However, when you are properly clearing a switch out, you're erasing its configuration, don't forget not only to do a write erase, which erases the startup config, but also do a delete /VLAN.dat. By doing that, that is the only way that you can erase your VLANs. I'll do a show VLAN, and you can see that they're still there. You might be thinking, well, Jeremy, I thought you just deleted it. They are memory resident. They're sitting in RAM. So we have to reboot this switch, just power it off and power it back on before those VLANs go away. So my point in telling you that, this is especially valuable when we get to VTP. When you're clearing a switch, don't forget to erase the VLANs or erase the VLAN database file. And that's about all I have to say about that. So let's wrap up VLANs. This has been the opening video on just creating VLANs, modifying ports, assigning them to VLANs. We talked about, first off, VLAN foundations, what VLANs are. We then got into the VLAN design, which primarily deals with local VLANs. Cisco wants you to make sure that you keep your VLANs constrained to the switch blocks so that they don't go through the core of your network. Last thing we got into was the VLAN configuration. Walking through, first off, creating the VLANs from either VLAN database or global config mode, then assigning your access ports to them. I hope this has been informative for you, and I'd like to thank you for viewing.